Let's talk about influence. Specifically, how do you measure it when the connections only go one way? Like on Twitter, you might follow a celebrity, but they're probably not following you back. Or think about how economic papers cite each other. These are called directed graphs, and figuring out who or what really matters in these networks is a super interesting puzzle. All right, let's get into it. So here's what we're going to cover in this explainer. We'll start by looking at why just counting followers or links is a bad idea. Then we'll get into why the quality of your connections is everything. After that, we'll break down how the PageRank algorithm actually works, look at a really clever fix for a tricky problem, and then wrap up by seeing how this all helps us find true influence in the real world. Okay, first things first, let's tackle the most obvious way to measure influence and see exactly why it's so flawed. So, if I asked you this question, what's your first instinct? You'd probably just count up the endorsements, right? Whoever has the most incoming connections wins. I mean, it's simple, it makes sense, and, well, it's completely wrong. This slide really nails the problem. Look at node A on the left. It has 10 endorsements. That's a lot, but they're all from kind of unknown, less important nodes. Now, look at node B on the right. It only has 2 endorsements, but they come from huge, highly respected players in the network. So who's really more influential? It's not about how many people point to you. It's about who is doing the pointing. And this really just says it all, doesn't it? An endorsement from an expert in the field is worth way, way more than a dozen from random accounts. We need a system that gets that distinction, because a simple vote count just doesn't cut it. All right, so if we can't just count endorsements, we have to figure out a way to weigh them based on who they're coming from. This is the big question, right? It's the exact problem the founders of Google were trying to solve for ranking web pages. How on earth do you decide that one link, one vote, is more important than another? Well, the answer they came up with is just brilliant. You let the network itself tell you. This is the heart and soul of PageRank. Your influence isn't some fixed score. A better way to think about it is like a liquid that flows through the network. An influential node doesn't just have influence. It passes some of that influence along to every node it links to. So if you get a link from a really high-ranking node, you get a huge boost. It's this beautiful, self-reinforcing system built on reputation. Okay, the principle makes sense. Your rank depends on the rank of others. But wait a minute. How do you actually calculate that? It sounds like a chicken and egg problem, where everyone's score depends on everyone else's score. The magic word here is iterative. You don't solve this all at once. Instead, PageRank is an algorithm that just runs the calculation again and again and again. With each pass, the scores get a little more refined until they finally settle down and stop changing much. It's a process of gradual discovery. So here's the play-by-play. At the very beginning, we just give every single node an equal piece of the pie. Then, in round 1, every node takes its current rank, divides it up, and passes it along to the nodes it links to. Then, all the nodes update their own score by adding up all the rank they just received. And then you just do it again and again. You repeat this process, distribute, update, repeat, until the numbers stabilize and the true influencers emerge. Now, there's a sneaky little problem with this whole process. What happens if influence flows into a dead end in the network and just gets stuck? This is where the algorithm shows its real genius. Exactly. Think about a web page that links to nothing. In our model, all the influence flowing to that page would have nowhere to go. It just pools there. This creates what's called a rank sink, basically a black hole for influence that skews the results for the entire network. So how do we fix that? The answer, believe it or not, comes down to this one number. It's called the damping factor, and it's usually set to 0.85. This little value is the key to making sure influence can never, ever get permanently trapped. The best way to picture how this works is to imagine a random surfer. So this surfer is just clicking around the web. About 85% of the time, they follow a link on the page they're currently on. But, and this is the important part, the other 15% of the time, they get bored. They ignore the links, type a new address into the browser, and teleport to a completely random page somewhere else in the network. That 15% chance means that every single node, even one with no incoming links at all, gets a tiny trickle influence in every round. It keeps the whole system flowing and makes the rankings much more stable and realistic. So we have this elegant, robust algorithm that can find the hidden centers of power in a network. Let's look at what this is actually used for. And this is why PageRank is such a game changer. It was literally the secret sauce that made Google's search results so much better than everyone else's. But its power goes way beyond just websites. You can use it to find the most important scientists by looking at who cites who. You can identify the real influencers on social media. Basically, you can analyze any network where a link or a connection implies some kind of importance. It's an incredibly powerful lens for understanding complex systems. And that kind of brings us to the final thought here. The big lesson from PageRank is that we have to look past the easy, surface-level numbers to see the real structure underneath. So the question I want to leave you with is this: where else in your life, in your work, in our culture, even in your own social circles, are you mistaking simple popularity for real, meaningful influence? Thanks so much for tuning in. If you found this breakdown useful, do me a favor and hit that like button. Share it with someone you think would be interested. And of course, subscribe for more explainers just like this one. See you in the next one.